Look left. That glitching face is the reality of AI video. Now look right. A perfectly stable character moving without losing their identity. When you write a massive, highly detailed text prompt for a video generator, you're asking the model to guess your exact vision from scratch on every single frame. The more words you add to control the character, the more confused the system gets, leading to prompt drift and burned generation credits. To fix this, we have to stop generating video first. Instead, we use a storyboard-first workflow, combining GPT Image 2 and Seedance 2.0 inside the LumaFlow AI platform. By generating static visual anchors to establish your scene before animating anything, you give the video model an exact reference to follow. Visual guidance beats text prompting when it comes to keeping a story cohesive. Before touching any AI tools, we need to create a locked character blueprint. This is a simple document that defines a strict, unchanging vocabulary for your subject. To make the AI's job easier, we apply a concept called the chromatic narrative. This means assigning specific, easily recognizable color palettes to your character, so their identity is immediately obvious on screen without relying on complex text. Animators have done this for nearly a century. Heroes are almost always designed using high-luminance primary colors, bright reds, blues, and yellows, while villains are typically draped in acidic secondary colors like lime green or deep purple. For our blueprint, we will lock in the age, physical traits, a specific primary color, and the lighting style. We'll use a 30-year-old man, short brown hair, a vibrant yellow jacket, cinematic lighting, and a modern thriller style. Because these core physical and chromatic traits are permanently locked into a master document, you never have to rewrite them. The AI receives the exact same signal every time, eliminating random variations between shots. Step 1. Open your LumaFlow AI workspace and initialize the GPT Image 2 model. Copy the exact text from your locked character blueprint and paste it into the prompt box. Now add the specific action for your first scene. For example, append "walking down a rain-slicked city street" to your base blueprint. Run the prompt and generate a grid of 6 to 10 static storyboard frames to test out different angles and compositions. This chart shows the massive difference in resource drain. Generating an image takes seconds and costs fractions of a cent, whereas waiting for a full video render consumes minutes and carries a heavy cost per attempt. By generating static frames first, you instantly scan the grid to verify if the facial structure and that vibrant yellow jacket remained accurate. If an image feels wrong or the face shifts, simply discard it and roll again. You are fixing mistakes at the cheapest possible stage. Once you select the best images from that grid, those static frames become your ultimate source of truth. They will dictate all the animation steps that follow. Now that we have our storyboards, switch over to the Seedance 2.0 interface within the LumaFlow AI workspace. Upload your approved static storyboard frames directly into the image-to-video input. These will act as your primary visual anchors. Because the AI can already see the character, the lighting, and the environment, you don't need a massive paragraph to describe the scene. You only need a simple instruction. Generate cinematic video following exact story, character, and framing and provided image. Forcing the model to rely on an existing, approved image rather than guessing from text gives you perfectly smooth, storyboard-accurate animation. Most AI video generators cap out at around 5 seconds per clip. Standard extend buttons usually cause the visuals to degrade, warp, or lose focus the longer they run. This diagram illustrates the leapfrog technique for bypassing that limit. You convert frame A into video A, and then take the very last frame of that video and loop it back into the image generator to serve as the seed for frame B. Feeding that final frame back perfectly preserves the environment and lighting for the next sequence. You then organize these sequentially generated clips and stitch them together seamlessly on a standard editing timeline. Using this iterative, frame-by-frame feedback loop ensures the character stays locked in, maintaining temporal stability over runtimes of 15 seconds, 30 seconds, or beyond. Here is the result: a seamless 15-second cinematic sequence. The yellow jacket, the face, and lighting remain perfectly stable as the character moves. Shifting the heavy lifting to the storyboard phase eliminates morphing and protects your generation budget. Now it's your turn. Open LumaFlow AI, finalize your character blueprint, and generate your first 4 foundational frames. With your consistent character locked in, the next step is building out the world around them. Click the link on screen to learn how to add realistic AI weather and lighting effects to your scenes.